Okay, welcome back to biology. My name is Mr. Kubuski. We're going to continue talking about ecology today. Today we're going to focus on the flow of energy through an ecosystem. Okay, so we've got some key ideas, some key questions I want you to think about as we go through. How does energy move through an ecosystem? We're talking about the energy like, metabolism. Remember we talked about that a little bit. The energy that living things need to survive, that kind of energy. Where does the energy go? Like, how come it's not there all the time? And then, why is it rare to have more than 4 different trophic levels? So, I know we don't know what a trophic level is, but we're talking about 4 different levels of like prey, predator, herbivores, omnivores, those kind of things. Okay, so think about those as we go through. So, how does energy move through? Obviously, you probably learned in elementary school. It's by a food chain. Okay, so what is a food chain? Okay, a food chain shows the flow of energy in an ecosystem. Now, I'm sure, like I said, in elementary school, you're probably taught, well, this eats that eats that, yada, yada, yada. But what's really important here is that you understand that energy is passed, not by the process of eating, okay, but energy is passed from, the first part of the food chain to the next, to the next, to the next, all the way to the top predator, the apex predator in that food chain, okay? So the arrows show the way that the energy is flowing from plants to herbivores, from herbivores to carnivores to another type of carnivore to another type of carnivore, okay? So in our notes, I want you to break your notes into 3 sections besides the key terms. So I have a second section here where we've broken it into 3 folds, okay? And when I want you to draw this exact food chain, including the arrows and the labels, okay, all the way on the left. So you're going to label producer, herbivore, and carnivores. Okay, now if I take a bunch of food chains from one ecosystem and put our one community or population, or excuse me, one community I should say, and I put them together, that creates what's called a food web. Food webs are interconnected groups of food chains that represent the entire ecosystem, okay? If I go back, okay, it's not just that these grasshoppers will only eat this type of plant, okay? They'll eat other types of plants, and these field mice won't only eat grasshoppers, okay? So if I take that idea of a food chain and I expand on it to all the things that are eaten or all the things that one thing may eat and connect them all together, okay, again, that would be known as a food web. But again, look at my arrows. The arrow only points in one direction, so that's showing the flow of energy from this sage here to the dragonfly, okay, or from the frog to the kookaburra. Okay, so those are examples of how energy is flowing through an ecosystem. Okay, now, each of these levels is known as a trophic level, okay? So it's a step in the food chain or food web. Okay, at the bottom you have our primary producer, okay? The secondly, or right above that, then we're going to have a primary consumer. It's the first consumer, meaning that they consume only producers, okay? And then from a primary consumer, I then have a secondary consumer. Secondary consumers always have to be carnivores because our primary consumer has to be an herbivore. Okay, now obviously the exception would be if it's an omnivore, okay, then it could be, maybe on both different levels, okay? But secondary consumers are usually some type of meat eater. And then tertiary and then quaternary, if there's a fourth one up there, okay? So in the center of our 3 sections here, I want you to go ahead and label the different trophic level: primary producer, primary consumer, secondary, tertiary, and quaternary consumer. Okay. Now, we said the energy flows, okay, from the plant to the hawk. Okay, well, think about how many plants. Look outside right now. How many different plants do you see? Okay, you probably see literally hundreds to even thousands, depending on where you're sitting. Okay, now how many hawks or different carnivores or apex predators do you see? You don't see very many. Probably one because they're hidden, but also two because there's not very many of them. Okay, there's not enough energy to support them in this ecosystem. Well, why? Okay, this is something along the lines known as an energy pyramid. And what this tells us is that at each level, each time we go from, like, let's say primary producers to primary consumers, we're going to lose 90% of the energy created by that level to heat. Okay, so these plants are actually going to give off heat. Now you're going to say, how do plants give off heat? Well, you got to think, okay, every time an organism, a living thing, goes through some type of cellular process, okay, part of that process is going to be lost. Part of the energy is going to be lost as heat because heat is created. Okay, a little tip: if you ever go camping or it's a cold winter night and you're trying to stay warm, you always want to eat something right before you go to bed because the different processes of digestion that are going to take place inside your body are going to produce heat. This is true even for plants. Okay, they have different processes that go on inside them called dark reactions that can produce heat. So again, every level, okay, you're going to lose 90%. Okay, so our primary producers, they are the original, producers of that energy that comes from the sun. They convert it during photosynthesis. Okay, only 10% of their total energy, of all the plant energy that's out there that's available for organisms to eat, only 10% of it is passed on to the primary consumer. The other 90% again has lost its heat. That same thing is true when I go on to the secondary consumer. Only 10% of this 10% is passed on, which is actually only 1% of the total amount of energy. The rest again has lost its heat. As I go to the tertiary, only 10% is passed from the secondary on to the tertiary. So I'm down to 1/10%. And again, if I get all the way to quaternary, then only 0.01% of energy from the entire ecosystem is available for these apex predators. Okay, so what this is telling us is that we're going to have less and less numbers as we move up. Again, thousands to even millions of plants outside, then you'll probably have thousands of bugs, and then maybe hundreds of mice, and then maybe a couple dozen snakes, and then you're only going to have a few hawks because again, only enough energy is passed on to support a smaller number each time you move up. This is known as an energy pyramid. Again, lots of plants, not as many primary consumers, even fewer secondary consumers, and then very few tertiary consumers. So this is why it's not very often seen. We usually don't see quaternary consumers because, again, not enough energy is available for them to sustain an entire population. Again, remember, we're not just talking about one, we're talking about a population. Okay? So why is it rare to have more than 4 trophic levels? Okay? There's not enough energy left at the top. There's less number of organisms at each level. Again, if I look at these, the J represents joules, which is a unit of energy. You'll learn more about that when you take chemistry next year. Okay, but again, if I have 1,000,000 joules of sunlight, okay, only 10,000 joules of that, okay, are produced in the primary producers. Okay, only 10% of that is passed on to the primary consumers. Only 10% of that is passed on to secondary consumers, and only 10% of that is passed on to tertiary. Okay, so I only have 10 joules. Okay, which means I would only have 1 joule of energy available for that quaternary consumer if he were there. Okay, if that's the case, and there's not enough energy to pass on, then I'm not going to have a quaternary consumer. That population will die out. Okay, so this is also known as a pyramid of biomass. Remember, biomass is if I took all the weight of every living thing in an ecosystem and weighed it dry, that's known as the biomass, okay? So if I have lots and lots of plant producers, because I have lots and lots of sunlight, well then I'm going to have more of everything else, which means I'm going to have a larger biomass. So that's why I have more biomass in places like the rainforest or something like that. But I'm going to have less biomass in a place like a tundra. Since there's not as much sunlight, there's less producers, which means there's less primary consumers, which means there's less secondary consumers and even less tertiary consumers. So again, the amount of sunlight that an area gets, that an ecosystem gets, has a lot to do with the types of animals and the number of animals that you're going to see in that area. Okay, so as the trophic level increases, the biomass or the numbers of animals at each level decrease. So there's only 1 hawk here, I have a couple of snakes, and etc. You kind of get the idea. So why are there not more hawks in this ecosystem? There's not enough energy, okay, available in the entire ecosystem to support their population. Okay, so how does energy move through an ecosystem? We talked about food chains. Okay, where does the energy go? Okay, 90% has lost its heat. Only 10% is passed on from one trophic level to the next. And then why is it rare to have? You can visit the website at mrkowalski.wordpress.com. Okay. If you want to go ahead and get started, this is a great activity on food webs and kind of putting them together. Type in this address, go have some fun with it. Again, if you have any questions, feel free to contact me. Otherwise, have a great day.